I'm José Bollo from Iot.bzh. I'm working for the company since 2015 at the beginning, and I collaborated to the construction of the security model of AGL, where I contributed for the application framework and the security model. I will present here our current work on implementing the security model on top of the SELinux security module. So thank you for your attendee to this talk. First, let's present our society. Iot.bzh is located in France. We are about 30 people working mostly on Linux embedded, and we contributed to AGL. At the moment, we are selling a solution based on AGL whose name is Iotbzh, and it's dedicated to a long-term support, and we sell it for maritime offers. Then our talk will present the stack of the security. It has to be recorded, then the existing tools and how we will leverage it. The current state of the framework, then jumping from the current state to the work we're focusing, we will present the work done for SELinux, and then we will try to have few words of conclusions. The stack of security. It's obvious that on a car you have electronic computing units, and on this electronic computing units, mostly if they are based on Linux, you will find probably tons of programs written with millions of lines of code. These lines are written by thousands of people, provided by 100 teams spread across the world, and that's a lot. It shows how complex systems can be. The other aspect is that on a car you will find dozens of local buses connecting hundreds of sensor or local device, maybe more than one ECU. And the trend is to connect it with clouds and probably dozens of cloud services. So it's a complex system, and no one can trust it like that. Why? Because of bugs, because of cybersecurity, criminality. Then the focus of the security is to limit the impact of bug, increasing the resilience of the system for minor faults. How to say that? Well, so bugs can have disastrous effects. We will try to isolate their consequences to small parts of the system to ensure resilience of it. Also, we want to limit effect of cybercriminality and its cost. Obviously, we want to ensure the privacy of customers. How to securize? The recipes are well known. We have to control the attribution of resources to programs. What amount of memory, how it can use the CPU, what storage, if it can, if it has duration limited in time, the device that it can use, how it can access network, etc. We also have to isolate applications one of another to ensure privacy of data, or for example that an application cannot kill another. Also, because cars are complex systems, many people are involved, for example the mechanic, or the maintainer, the owner, the simple user, the children. So identification of the role of people is important, because some of them can do things, some other can't. Also, some rules of security are under consentment explicit. It means that it's dynamic. It's always forbidden, you cannot do that, but you can say, this time I want to do that. So we have to deal with static security that cannot be changed, and with dynamic security that can evolve and adapt it to the needs and the user. The existing tools, then Linux provides a lot of tools. We can see the most old one first, that are discretionary access control. It's linked to Unix users, groups, and process identifiers. It's possible to increase this policy using the access control lists. Also, capability is interesting because it allows to split special rights that are important if you want, for example, to create something, a new user, a new group, and that's the capability, for example, that is named capture, from the capability of stopping different processes. So it can split the rights in small parts, in small pieces, and you can atomically give some rights to an application or not. Cgroups are also of importance to control the CPU usage. We can also name seccomp and PRCTL that are used for the process control. One of the most important trend offer is namespaces that are used for light containerization and isolation of application and sharing users, processes, network, files, etc. And the one that we are focused on this presentation is the mandatory access control, that is Linux Security Module. Linux Security Module at the moment cannot be mixed. You have to choose one. So you can choose loadpin, setid, SMAC, SELinux, AppArmor, Tomoyo, and some others. I noted here for the mandatory access control, SMAC is the one that we use currently on AGL, and SELinux is the one that will be another choice in the future. It exists also about Linux framework tools. These framework tools are hardware isolation with the trust zone, that is a special hardware isolation proper to ARM. We can also on some SOC find multiprocessor, asymmetric multiprocessor, and in this case you can use, for example, an embedded operating system neighbor to Linux and connected to it on the same chip. Here you can have interest to see the presentation of my colleague Julien Massot on the OpenAMP implementation on Zephyr. You can also find hypervisors and light container, for example. Some of them are used, Flatpak, AppImage, and we also provide a new light container whose name is Redpak. Well, let's focus on the current state of the AGL application framework and its security model. At the time, the security model has two main parts. One part is dedicated to the security by the kernel, and it uses SMAC mandatory access control. This filters system calls, and if an application tries to either a black hat application or an application that violates its rights for another reason, if the application don't do what is expected to do, it blocks it at the kernel level. Synagora is another part of the security model. It's dedicated to the dynamic authorization and service applications that are not really linked to the kernel, but that are linked to the services. So services can define permissions that you must have to access its resources. And that's the goal of Synagora. It's a model that is inspired by Tizen security model, and it's in AGL since 5 years now. Well, another aspect is that the AGL security framework uses systemd activation for launching its application, and it's a very convenient thing because systemd has many security features like integration of cgroups, PRCTLs, setcomps. You can also limit network access, set the security context, etc. It also links on Unix users to separate data between different users. Then it provides an application management and packaging. So applications comes with their files, contents, programs, etc. It's put in a package with digital signature and a configuration files that describes the security requirements of the application, and these requirements are granted by certificates. When the application is installed, the framework scans the package, installs the files, and from the configuration of the manifest of the package, it derivates from template and configuration files, the systemd files for activation, and insertion of the package in the system. And it involves the security manager to set the security, for example, the security of the files, of the installed files, setting their context, creating the rules, the SMAC rules of security, and providing Synagora rules for the dynamic security. So, coming from this AGL model, we had to create something that is compatible with SELinux, Security Enhanced Linux. Well, how can it be done and why? So the reason to move from SMAC to SELinux is that despite its simplicity and lightness, the adoption of SMAC is little. There is no sign of upward trend, and in some occasion we are limited by SMAC without seeing how it can evolve in near future. So we have to try something aside. That's good because the underlying implementation of the security model of AGL is not fixed to be SMAC. Conceptually, it can be anything. So it's a good occasion to challenge the model. Another aspect that is important for the choice of SELinux is that there is an Iotbzh policy database that can be used for free and that is maintained by the community. So then the main idea is to extract SMAC and just replace it by SELinux. Synagora will remain. How to do that? Well, the first idea is to just update the security manager and the configuration and templating files. But we seen that it was important to improve the API of the security manager. Then just replacing or updating the security manager is not enough. We have to rebrand, redesign it to have a new security manager with improvements that are more compatible with SELinux and that can also handle correctly SMAC requirements. Then, if the security manager and its API changes, we had to also update the installer and to provide new things for the security manager. The installer was also updated to be compatible with RPM installation. Then, when the security manager is provided with the good rules, it will generate 3 files: the type enforcement file, the interface file, and the file context file. These files are generated from templates that we will show later, and it is used first to set the context of the installed files, then to create a policy, that is installed and increase the set of policy of SELinux. So the main affair is here to have the good templates to create the good rules for SELinux. Let's see our draft. Our draft, here we have the declaration of the types, the SELinux types. So here it's a template file. So you can see it comes from the templating comes from the previous security manager. So tilde app tilde means it will be replaced by the identifier of the application. So it means that this will create how many? 7 types that are application type, application library type, etc. Intend to tag files that are installed, and also to set the type of the application. Then these types are used to create rules on domains. We have here the templates that create an init domain, meaning that the application can be started by the init process. The second template rule is the domain entry file that states that the process whose type is being typed can enter the application type. These rules are set in template files and can be set up system by system without changing the security manager. Here is an example of a rule that a template rule that allow the libraries items to read files and execute them. Here we show how it's inserted in the SELinux standard processes by using standard SELinux defined names. The templating also includes systemd settings. There is an example that shows how the SELinux context is set using systemd for the launched application. On top you can see the definition of the macro, and on the bottom you can see the effective rules. What is important also here is to see that we create in the same systemd service file the 2 lines, one for SMAC and one for SELinux, meaning that at runtime systemd knows what is the current security active, what is the current active security, and switch the good context. Then installing SELinux rules at the moment is a process that is in 3 steps. Generates the policy files from the template, compiles the files to SELinux module compiled file, and load the module into the policy. That last step is the step that is the longer. We set here the time it takes. So, for example, for installing a simple application with a minimum policy, what we measured was that it took 2.5 seconds. With the full policy that you can find on some major Linux distribution, the time increase. That's one of the aspects that we want to work on. We'll speak about that later. Then let's see what we have done at the moment. So we full rewrite in the security manager. I have to note here that it's for SELinux, but it works for SMAC. So the current implementation that you can find is you select when you compile it if you want SMAC or SELinux. We adapted the application framework. Here again, the same application framework, the same program can run for SMAC or for SELinux. This is integrated within RPM installation. We have studied a set of SELinux rules and template policy. And the main contributor of this work is Arturo that I want to thank here for its work. You can find that work on our GitHub repository. It's part of Iotbzh Core Subsystem. The names are SELinux Manager for the Linux Security Model Manager, and AFB App Manager, that is for the Application Framework Binder Application Manager. Conclusions. Well, yes. So the security model of AGL is now challenged for the security model, abstraction of the security model. And we have to say its reliability is proven now. We can trust that we can switch from SELinux to SMAC. Well, it's still in early alpha stage, and it needs more testing. But we think we are close, and Iotbzh is close to support either SMAC or SELinux as a solution for its security base. Well, and it's used to provide a complete solution from sensor to cloud. Yes, because it's a more global thing to provide a solution for such items. So we have here either SMAC or SELinux that secures Linux embedded target, but you can find here Synagora that is used for the protection of services. You can see here a firewall. You can see here a federated identity that is used to check identity, for example, using here social identity or Google identity, and gives permission using a permission agent to the overall system. Also, even for Zephyr and tiny embedded system for an asymmetric multiprocessor, the security is ensured either by the kernel, but also by an application that is able to give the trust of the request from coming from a cloud to the sensor. Well, next step, we envision to add AppArmor case. We also have to make some improvement to the solution. So the rules and the compilation times are to be checked, improved. We have to add permissions following the use case, so refine rules. We have to also improve the templating of rules, because we found now that the templating files and format coming from the security manager is not well suited for our need. We have to increase it with, for example, conditionals. And this templating could be replaced with a more efficient templating, like the one we use for the application framework using Mustache. Also, we want to have a better integration with new binder features, using, for example, TLS and extensions of the binder to provide a cohesion framework. We have to also work on the link on the role-based permission using a federated identity. Another aspect is that Redpack, that is a light containerization solution for us, is to be taken into account, and we want to have, with the same solution, to create installation files that will be then exploited by these components. Also, we found that, especially for the integration with Redpack, the widget format has to be improved. We already have an implementation running on RPM, and that can be installed using DNF, for example. And we want to improve the configuration file for the new set of rules for Redpack, for SELinux, for connection of services together, connection with OpenID Connect, identification roles, etc. Well, we're done. Here is a picture of the Rade of Lorient, where we all live and where we expect to see you soon. Time for question now. Thank you for your attention.